All right, so we're going to start with the square root of x minus 7 over x plus 8 dx. And the problem said that we needed to replace u as the square root of x minus 7. So when I did that, I got u over x plus 8, and I needed something to cancel out the x. So what I did was I isolated x, which means that I had to square both sides to get x by, you know, x to the first power. And then I isolated x to get u squared plus 7. So from there, I can replace the x with u squared plus 7, and then, of course, I need to switch out my dx with du. So doing that, I end up with, it was easiest for me to do that with the u squared equals x minus 7 version of our equation rather than having the square root. So I did 2u du, since it's implicit differentiation, is equal to dx, plug it in for dx. So 2u times du, then multiply u and 2u to give me 2u squared over u squared plus 15. And now this is starting to look a little better, believe it or not. Now the denominator's degree is the same as the numerator, so this is a good time for us to try long division. So the numerator goes inside the inside, and the u squared plus 15 goes on the outside. So u squared times 2 gives me 2u squared. I distribute to giving me 2u squared times 30, or plus 30. Subtract, so my 2u squares cancel, and then 0 minus 30 gives me a remainder of negative 30. So I get a remainder of negative 30 over u squared plus 15. From there, I'm going to substitute that into my integral. So I have 2 minus 30 over u squared plus 15, which looks a lot nicer than what I had, because I can take the integral of 2, and then I could take the integral of the fraction part, 30 over u squared plus 15. And I recognize this fraction, the u squared plus 15, as the integral of arc tangent. So I set my v, since I'm already using u, I use v equal to u, and a is equal to root 15. Okay, so I integrate 2u minus 30 was on the top, and then I multiply by 1 over a, so 1 over root 15, arctan of u over root 15 plus c. The last step is to substitute in my u value, which is way up here, the square root of x minus 7. So it's 2 times the square root of x minus 7 minus 2 root 15, because I rationalize the denominator, times arctan of root x minus 7 over 15 plus c. So this long division is when we use the numerator's degree is the same as the denominators, or if the numerator's degree is higher than the denominators, then I can use long division.